Hello, this is our second example. In fact, I just realized I didn't put example 2. So this is our independent samples t-test example 2. It's very similar to the first one in that we're looking at if there is a difference in test scores between students who attended the study session and students who did not attend the study session. So once again, we have those who did not attend the study session, those who attended the study session. Our two variables are just the categorical one of did they attend the study session, yes or no, and then what their test score was. And these are the different test scores, which are numeric. So we have one categorical variable with two answer options, and then one numeric variable right there. So what we're going to look at is the independent samples t-test because we have independent groups that are numeric, and we want to know if there is a difference. Our hypothesis is that there is no difference in test scores. That's our null, is that there's no difference, and our alternative is that there is a difference. We're going to go ahead and run the test in JASP. Now, because we just ran very similar data, and it does take a little bit of time to set up, I just went ahead and put it in JASP right here for us. So you can see this is how you would set it up, right, like that to look like. So there's the data, and oops, sorry, right there. And here is what that looks like in JASP. So once again, you've got that categorical variable of study session, did they attend, no or yes, and then you had the test scores. So you can see that I've got all of this data in this format. And if you want to know how to do that, go back and watch that first example because I go through in detail how to set that up. But I just didn't want to do all that detail again for this video. So we've got the data in, we've double checked it, and then make sure you come up and do a save as and save your data. So make sure you have your data saved. Once you have your data saved, you're then going to come up to t-test, independent samples t-test. Remember our dependent variable, that's the thing that we're measuring, and in this case it's test score. Then study session is that grouping variable. So we have initially our p-value right there, but we need more information. So we're going to add our normality, our quality of variances, make sure to switch to Levine. So double check, make sure you do have that change to Levine. We then want effect size, and we do want Cohen's d, and we want those descriptives right there. So this is all of the data that we want right there. Make sure, get your little snipping tool or whatever, and take your screenshot of the data. Make sure to save that into your Word document or somewhere where you will have access to it. So now that we have access to the data, let's go ahead and look at the statistics and the results. So the first thing we're going to do is check that Shapiro-Wilk p-value. So Shapiro-Wilk is right here, and remember what we want a big p-value indicating the data is normal. Unfortunately, in this case, our p-value is small, which is indication that we do not have normally distributed data. There's some kind of outliers, there's just extreme stuff, whatever it is, data is not normally distributed. Now, if the data is not normally distributed, it doesn't really matter what the Levine's test is. We're just going to go ahead and switch to the Mann-Whitney. I will say that if the inverse is true, so let's say that Shapiro-Wilk is good, but Levine is too small, you would still go ahead and switch to the Mann-Whitney test. So basically, if either this Shapiro-Wilk p-value or this Levine's p-value, if either one of those is smaller than 0.05, so if either one of them is smaller than that p equals 0.05 or is equal to or less than 0.05, then you will just automatically switch to the Mann-Whitney test. So it doesn't matter which one, could be both of them or either or, you're going to go ahead and switch to the Mann-Whitney test. So in this case, because Shapiro-Wilk is less than or equal to 0.05, our data is not normally distributed, we're going to have to switch to the Mann-Whitney test. Now, I did go ahead and include, how to interpret Levine's, and, the variances are not significantly different, but once again, because this Shapiro-Wilk is not normally distributed, it doesn't matter that Levine is okay. This one kind of overrides this one being okay. So we're going to go ahead and do the Mann-Whitney test. It's pretty straightforward and easy to do. You're just right here while we are in that independent samples t-test, we're just going to go ahead and check the box for Mann-Whitney and uncheck student t. Now, we don't need the effect size and all of that other stuff. We really only need now this independent samples t-test, this U-score, because it's a Mann-Whitney U-test. We need this U-test, we need this p-value, and we need the rank visceral correlation. So we only need those three numbers there, which you can see. I've got those, the 1, the less than 0.001, and that rank visceral correlation. But as part of the Mann-Whitney test, instead of comparing the means between the two groups, the Mann-Whitney test actually is comparing the median values. So what you do need to find is the median value for each of the groups. And to find that median value, you're going to come up to this main top level descriptive statistics. You're going to click descriptive statistics. Now our variable is the test score, because remember that's what we're trying to find, but we're going to split it out by study session because we need the median for each group. Then underneath statistics, we do need that median value, but we don't need any of these other values. The only one we need is the median. So we can go ahead and uncheck the rest of these, and that is the median. And that's going to replace the mean because for this Mann-Whitney test, it's actually comparing the medians, not the means. So go ahead, copy that over so you can see this is the new information right here that we will be using. So the Mann-Whitney U-test information and the median values for our two different groups. So scrolling down, how do you interpret the Mann-Whitney p-value? It's the exact same as any other statistical test p-value. If p is less than or equal to 0.05, we will reject the null. So that means with our p-value of less than 0.001, we do have significant Mann-Whitney test results, and we will reject the null. Now if we go down to how to interpret the rank visceral correlation, it is an effect size measure to quantify the strength of the association between two groups when performing non-parametric tests, like the Mann-Whitney U-test. Well, if you look at our value, that's negative 0.972, and so that falls into a large negative effect. So we've got it large negative effect because it was that 0.97, so negative 0.97, and that falls into this large negative effect. Now, for the written results, you do start with an independent samples t-test was performed to determine if there was a difference in test scores for students who attended the study session and those that didn't attend the study session. You're going to go ahead and include that null and the alternative. Then you would say that a Levine's test found that the assumption of homogeneity of variance was met. Now, granted, if it wasn't met, you would just say that it wasn't met. And then a Shapiro-Wilk test showed that the groups did not have normally distributed data. And so you can see no normally distributed data. Because of the Shapiro-Wilk value, the assumption of normality could not be established for the independent samples t-test. Instead, a Mann-Whitney U-test was run to determine if there were differences in test scores for those who attended or did not attend a study session. And so once again, as a reminder, if the Levine test did not meet the assumption of homogeneity of variance, then you would go ahead and switch to the Mann test. So even if Shapiro-Wilk was okay, if Levine wasn't good, you would still switch to the Mann-Whitney. If Levine and Shapiro aren't good, you will still switch to the Mann-Whitney. The only time that you would just go and do the straight independent samples t-test is if both Levine and Shapiro-Wilk are okay. So instead, a Mann-Whitney U-test was run to determine if there were differences in test scores for those who attended or did not attend a study session. Test scores were significantly, once again important, make sure to include that significantly different between those who did not attend the study session, and this is where MDN is median, make sure to italicize that, is 67, and those who did attend a study session, MDN, median, is 82. And that came from these median values right there that we got from those descriptive statistics that we ran. Then you do comma, and so this is different. For that Mann-Whitney, you do not provide a degrees of freedom. Instead, you just have an italicized U is equal to whatever the U value is. In this case, it's 1. And then we've got P is less than 0.001, and so that just comes back to right here, it's less than 0.001. The null hypothesis was rejected. Really important. Make sure you say that that null was rejected. The rank bistral correlation was 0.13. So here we go. Oh, that's not correct though. The rank bistral is negative 0.972. Oh my gosh, I'm sorry. There we go. Okay, the rank bistral correlation was negative 0.972, indicating a large negative effect size, with those attending the study session scoring higher than those who did not attend the study session. So those are the written results for the independent samples t-test if you have either an issue with Levine or Shapiro-Wilk and you need to switch to that Mann-Whitney non-parametric U-test. Now, we won't just be doing a Mann-Whitney U-test just in general, so there's not going to be a video just for the Mann-Whitney U-test like there is for a Spearman test. So if you have any questions about it, let me know. But really, what I showed you up here, it's pretty straightforward in terms of just, checking the box. Just checking that Mann-Whitney box and getting those results, and then coming up to descriptives and running, getting that median value right there. That's really all there is to it. So I hope this helps, and if you have any questions, let me know.